Good morning, students. So, as an important university question, this is an important university question. In this video, what we are going to see is an important university question, that is protection against over voltages. So, what are the various methods of protection against over voltages? So, it is an important point. Before going into the video, I will tell one thing. Go through all the titles and diagram, how it works, kindly understand, and then you practice it in a separate notebook so that you can score maximum marks. So let me go through to the video directly.
In today's session, we will be seeing about what is over voltage and how to give the protection against over voltage. So if you note, there are several instances where the elements of the power system such as generators, transformers, transmission lines might be subjected to over voltage. It can be either due to the lightning, that is a natural phenomenon, or it can be due to the opening of circuit breaker, that is due to the switching over voltage, or it can be due to the grounding of conductors. So whenever we are going to consider the over voltage, what does it mean? So this over voltage, it is nothing but the magnitude of the voltage is going to be twice, thrice, or 5 times the normal values. So if these over voltages are allowed to persist in a circuitry or in a power system, so it might lead to the damage of the equipments. So as power engineers, it is our utmost duty to limit this overcurrent or to find out the means and the ways or devise some equipment so that we are able to limit the overcurrent and we are able to overcome these over voltages, and we are able to safeguard our operating equipments. Now here, what is voltage surge or transient voltage? So this voltage surge or this transient voltage, it is nothing but, when I say it as the over voltage, it is nothing but a sudden rise in the peak of the voltage. So a sudden rise in the voltage which is going to exist for a very short duration of the power system, it is usually referred to as a voltage surge or a voltage transient. So when I say it as a voltage surge or a voltage transient, it is nothing but the main drawback is that it leads to the insulation breakdown. So now we will analyze the lightning discharge waveform. So as I told you earlier, this lightning discharge waveform, it is nothing but they are going to be a transient. It is going to exist only for a short period of time or a shorter duration. So in this case, if you are going to see, it is just going to be there for 100 microseconds or 50 microseconds. But even such high magnitude of the voltage might lead to the equipment failure. So it becomes utmost necessity that we devise some device so as to protect this lightning waveform against from the equipments to be protected. Now here a graph has been drawn to represent the characteristics of lightning discharge. Here it is nothing but a graph is drawn between the voltage and the time. It is a VT curve. Okay, here if you could see, here the magnitude of the voltage has been put up, and whereas here the time has been represented. If you could see, observe this lightning waveform, it is a very steep fronted waveform. If you could see here, the characteristics has been represented as T1 bar T2, that is 1 bar 50 microseconds. So what does it implicates? It is nothing but here the waveform rises at a very high speed of 1 microsecond. As I told you, it is a steep fronted wave. You could see the voltage buildup or the voltage rise. It reaches its peak value within 1 microseconds, whereas it falls to 50% of its value. EM by 2. Whenever we are taking your rise time, we are taking the full magnitude of EM. Whenever we are going to take the fall time, we are just going to consider when it decays to 50% of the value. So that value, it comes to be 50 microseconds. So whenever I would like to express a lightning waveform, it is nothing but I will express in terms of the rise time bar the fall time. Fall time is nothing but it reaches how much time it takes to reach 50% of its value from the maximum. Now T1 bar T2, it is called as 1 bar 50 microseconds. Either I could tell this as a rise time bar fall time, or I could also represent it as wave front. The rising part is called as a wave front, whereas the discriminating or your diminishing part, okay, that is decaying part, that is called as your wave tail. So either I can express in terms of wave front or wave tail, or I can represent in terms of rise time and fall time. Here, if you are going to see, usually this rise time, it lies between the range of 1 to 5 microseconds. Since this is a very high steep wave, so it becomes utmost necessity that we have to protect the device either by using lightning arresters or by using some other means. So with this, I conclude today's session. In the next session, we will be seeing about what are the causes of
Dubai.
So with the protection against over voltages, the unit 1 is over. So in the next unit 2 deals with breakdown. What are the various types of breakdown? First one is gaseous breakdown. We will see in the next video. Thank you.